Good morning students, welcome to our next lecture of data structures and algorithms. Today we will study our topic Towers of Hanoi. It is one of the most important topics of stack data structure. In this we will study how we can solve a puzzle of disks using the different number of towers. So it is we can say that it is an application of stack data structure because we are storing the disks according to the stacks. That means one disk is stored above the other, and if we want to remove the disk, only one disk can be removed at a time, and that disk too should be the top one, like we studied in the stack operations. So let's start with this topic, Towers of Hanoi. It is a mathematical puzzle which consists of 3 towers. We can say that it is a kind of mathematical puzzle which we will be solving. It consists of 3 towers. So these are the towers of this puzzle, and it can have more than 1 rings. That means we can have 2 rings and then we can solve that puzzle. 3 rings, 4 rings, we can easily solve, but rings must be more than 1. So here we are having 3 rings, 1, 2 and 3, and 3 towers. The aim of this puzzle, the aim of this mathematical puzzle is we want to move these disks from one tower to another tower without violating the sequence of the disks. Sequence of the disks means without violating the sequence of the disks, or the arrangement means no smaller disk can be arranged over another smaller than that disk. That means no smaller disk can be arranged below the larger disk. Only disks can be arranged in ascending order. That means smallest disk first, then greater than that, and at last the largest disk. So according to this figure, according to this diagram, we are having 3 disks. Disk 1 is the smallest, then disk 2 is larger than disk 1, and then disk 3 is the greatest disk. So let's study the rules of solving this mathematical puzzle. The main aim of solving this puzzle is that we have to move the disks from one tower to another tower without violating the sequence of the arrangement, without violating the sequence of the arrangement of the disks. That means we can consider this as tower A, then B and C. So according to this puzzle, we have to move disks from tower A to tower C using an intermediate tower B. We can use this second tower, the intermediate tower B, for moving the disk so that our arrangement of disk does not get violated. So we are using an intermediate tower for moving the disks from source tower to destination tower. So here B is our intermediate tower that we will be using for moving our disks from tower A, that is the source tower, to tower C, which is the destination tower to which all the disks should be moved. Now first step states that only one disk can be moved at any given time. At any particular given time, at any given step, we can only move one disk at a time. That means we cannot move 2 disks together. We can only move one disk at a time in one step. Next rule states that only the top disk can be removed. As we studied in stack operations, when we were inserting the elements in the stack, we were inserting one above the other. But whenever we wanted to pop the elements stored in the stack, only the element stored at the top was popped. We just cannot pop the element in middle of the stack. So similarly in this puzzle, we can only remove the disk that is stored at the top of the stack. And third rule states that no large disk can sit over a small disk. That means smaller disk should be placed above the higher disk or the greater disk, as given in this example. First one is the smallest, second one is greater than first, and third one is the largest disk. So we cannot place 2 above 1 or 3 above 2 or 1. So this rule should also not get violated. Now the important point that we should always remember is the Tower of Hanoi puzzle can be solved in minimum 2 raised to power n minus 1 steps. Here n denotes the number of disks that we are having to solve. So always keep this formula in mind, always remember this, that Tower of Hanoi puzzle with n number of disks can be solved in minimum 2 raised to power n minus 1 steps. We will implement this formula. Now let's understand this mathematical puzzle through an example. Here we are having an example in which we are having 3 towers A, B and C and 3 disks. Smallest disk is denoted by red, then the disk greater than the smallest disk, and the largest disk is denoted by green. So now let's start moving the disks from tower A to tower C, so that we can move all the disks to tower C without violating the sequence of the disks. So in first step we moved smallest disk to tower C. Smallest disk was moved to tower C. In next step we moved the second disk denoted by white, second disk to the intermediate tower B. Then in third step what we are doing, we are moving the smallest disk back to the second disk denoted by white. According to the rule, we can insert a small disk above the greater disk. So in third step we moved the smallest disk to the above the second largest disk. In fourth step we moved the largest disk denoted by green, largest disk to the tower C. Then in fifth step we moved the smallest disk back to tower A, smallest disk back to tower A. In next step we moved the second disk, second largest disk above the largest disk, and in last step we moved the smallest disk above the second largest disk in tower C. So in this way we can move 3 disks using the 3 towers from one tower to another tower, that means from source tower to destination tower without violating the sequence of the disk. That means the disks are arranged in increasing order, that means first one only smallest disk, then greater than that disk, and at last the largest disk. So here we moved all the 3 disks using the intermediate tower B from source tower, that was A, to destination tower C, and our rules also not get violated. So in these steps we solved this puzzle using 3 disks. Now if we want to calculate the number of possible steps, the number of minimum steps to solve a Tower of Hanoi puzzle with n discs, we can easily implement the formula 2 raised to power n minus 1. Here 2 raised to power n means the number of discs. So here in this example we are having 3 discs. So here the value of n will be 3. 2 raised to power 3 minus 1 will give us 7 steps. So before solving any puzzle with n number of discs, we can assume, we can calculate the total steps that will be required to solve the puzzle. So before solving this puzzle, we can just calculate the steps by implementing this simple formula. We can just calculate the steps, and according to these steps we can easily solve our puzzle. Similarly, we can solve for 4 discs, 5 discs, as many number of discs. But the thing that is always kept in mind is that whenever the number of discs are increasing, the number of steps and the complexity of the program will also increase. So this is the basic example, basic and the simplest example of Tower of Hanoi problem, and it is one of the most important topics from exam point of view. I hope you all have understood. Thank you very much.